energy has a very close relationship with forces. It requires a force doing work on something to change the energy of the system. And we've talked about lots of different kinds of energy. There's gravitational potential energy, the energy that something has just because it's up high in a gravitational field and can fall. Kinetic energy, the energy of motion. Thermal energy, which is essentially the kinetic energy of the little atoms and molecules in a substance. There's chemical potential energy, which is ultimately due to the electromagnetic interactions of atoms and molecules in a substance. So chemical potential energy we're familiar with in food, coal, oil, natural gas, and by having chemical reactions with those substances, the molecules and atoms rearrange themselves and liberate some of that stored chemical potential energy. Well, what's really going on inside there? Inside the atoms and molecules, they are sharing electrons and bound to each other through the electromagnetic force. So in our daily lives, we're more familiar with gravity as a force, but the electromagnetic force is actually all around us, and we just don't realize it. The reason that I can't put my hand through the table is not because the particles of my hand are touching the particles of the table. It's because the electrons in the atoms that make up my hand are getting close to the electrons in the atoms that make up the table, and they're both negatively charged, and they push each other apart. And that very strong electromagnetic force is what we feel there. And it's that electromagnetic force that holds molecules together, sort of bunched up like a spring, and then we bring oxygen in to combust it or oxidize it, burn it, and that unlatches those springs and it lets those atoms and molecules fly apart with a lot of kinetic energy, and that is burning or liberating that stored chemical potential energy, which we can then do useful things with, like boil water to produce steam, to turn a turbine to produce electricity, or power our muscles in our body if that oxidation is happening on the cellular level. So this demonstration is just to illustrate that there is such a thing as an electromagnetic force. I can describe all that, but let's actually take a look at it. So what I've got here, two different rods of different materials. It doesn't really matter what they are. So I'm going to rub the clear rod, and the friction here, what's actually happening, the reason I'm rubbing that, is the friction is adding or removing electrons to that rod. I don't know which. I'm now going to rub this other rod with the fur, and that's going to do the opposite. One of these things I know from after the fact is gaining electrons, and the other one is losing electrons, so they will have opposite charges. And you can see, in fact, that this rod is attracting the other. It's not touching it, but it's attracting it, and it's causing this rod on the pendulum to rotate. So there is obviously a force acting between these two rods, and that's the electrostatic force. There must be some property of these two things that is causing that attraction. And if I was able to get the two rods to attract each other, so there was some property about them that was some force, obviously not gravity, that was causing that attraction. We know it's the electrostatic force. We know opposite charges attract, so I must have placed opposite charges on those rods. Let's try to place the same kind of charge on two rods. So I'll take one of these white plastic rods and rub it with the fur to put some kind of charge on it, and then I'm going to charge another rod the same way, so that now these things have the same charge, and let's see what the interaction is. And in fact, you can see that rather than attracting each other, these rods are now repelling each other. And so that's experimental proof that like charges repel each other, and the other ones that were attracting each other when we had a white rod and a clear rod, they must have been unlike charges. So that is the electric force is a real force. It can do real things. It can move things around. And it's that electric force acting on the atomic and molecular level that gives things like coal, gasoline, and food their stored chemical potential energy. They're bound up in a certain way, like a spring, and chemical reactions can liberate that stored chemical potential energy.